All right, welcome back, everybody, for another deep dive. Today, we're going to be talking about optics.
Optics.
You know, the science of light.
Yeah.
We've got some cool excerpts here
Oh, cool.
from a textbook. So we're
Yeah.
going through and talking about, the very basics.
Okay.
All the way through some really cool, I think, really mind-blowing applications
Yeah.
of optics. I mean, you
Yeah.
think about, have you ever wondered how glasses work?
Yeah.
Or fiber optics?
Yeah.
How is it that we can send information, across the globe at the speed of light
Right.
using, these little tiny fibers?
Yeah.
It's pretty amazing.
Yeah, it is. And I think what's really cool about optics is it's not just about what we see.
Yeah.
It's about the fundamental nature of light itself
Right.
and how it interacts with the world around us.
Yeah. Okay. So let's start just real basic.
Okay.
What is optics?
So, I mean, the simplest definition of optics is the study of light.
Okay.
And how it behaves, But it's not just the light that we can see. It's the entire electromagnetic spectrum. So, you've got infrared, ultraviolet,
Yeah.
X-rays. All of that is part of optics.
Okay.
And what I think is really cool about it is that it's both theoretical and applied.
Right.
So it's not just equations on a chalkboard. It's
Yeah.
how we actually use that to build stuff.
Yeah. And I think that's what's fun about these deep dives is that, we can look at the theory
Right.
and then see how it's actually applied in, the real world.
Yeah, exactly.
Okay. So let's talk about some of these basic concepts.
Okay.
One of the things that this text talks about is the dual nature of light.
Yeah.
What does that mean?
So this is where it gets really kind of mind-bendy.
Okay.
Because light acts as both a wave and a particle.
What?
Yeah.
Hold on a second. So it's like a wave, like a wave in the ocean.
Right, exactly.
But it's also like a little piece of matter.
Yeah. So the particle is called a photon.
A photon.
And this idea is called wave-particle duality.
Duality, yeah.
And it's a really fundamental concept in quantum mechanics.
Okay, so this is blowing my mind a little bit. So one photon
Yeah.
can be both of those things.
It can be both at the same time.
That's wild.
Yeah.
How is that possible?
I mean, that's the beauty of quantum mechanics. It often defies our everyday intuition.
Yeah.
But the way to kind of visualize it is, when a photon is traveling through space, it spreads out like a wave. But then when it interacts with matter, it acts like a particle.
Oh.
So it kind of depends on how you're looking at it.
Okay. So we've got light. It's both a wave and a particle.
Right.
What else? What else can it do?
Well, I mean, we all know light can bounce off surfaces,
Right.
like a mirror.
Right. Reflection.
That's reflection,
Yeah.
exactly. But then there's also refraction.
Refraction, yeah.
And that's when light bends as it
Okay.
passes from one medium to another.
Okay.
So from air to water.
Right. Like if you put a straw in a glass of water,
Exactly. That's a perfect example.
it looks like it's bent.
Yeah, it looks all wonky.
Right.
And that's actually how your eyeglasses work.
Oh,
They bend the light
right.
to help focus it on your retina.
So it's the bending of the light that helps you see.
Exactly.
That's pretty wild.
Yeah.
Okay, so you also mentioned diffraction
Yeah.
and interference.
Yeah.
And those sound kind of like the wave part
Right.
of this whole thing.
Exactly. So diffraction is when light bends around obstacles
Okay.
or spreads out after passing through a small opening.
Okay.
You can kind of think of it, it's like, if you have ocean waves
Yeah.
and they hit a pier,
Right.
the waves will bend around the pier.
Yeah. Okay.
Light can do that too.
So wait, is light bending around corners?
In a way, yes. I mean, it's not bending
Right.
like you would bend a pipe,
Right.
but it's spreading out
Yeah.
like a wave, which means it can reach areas that would otherwise be in shadow.
Okay.
And that's really important for things like microscopy,
Right.
where we use diffraction to see really tiny objects.
Oh, wow. Okay.
Yeah.
So we got reflection, we got refraction, diffraction. Interference is the other one.
Right. So interference is what happens when you have multiple light waves and they combine. And when they combine, they create these really cool patterns
Okay.
of bright and dark areas.
Okay.
The best example of this is the colors you see in a soap bubble?
Yeah.
That's light interference.
Huh.
Yeah.
Okay. All right. So we got all that. That's already 4 things.
Yeah.
What else can light do?
Well, there's also polarization.
Polarization.
And this has to do with the direction that light waves vibrate.
Okay.
So have you ever worn polarized sunglasses?
Yeah. All the time.
Yeah, me too. Especially when I'm out on the water.
Yeah, fishing.
Fishing, exactly. They cut down on that glare, right? And the way they do that is by blocking certain orientations
Okay.
of light waves.
Right, right. So it's only letting certain, like, vibrations through,
Exactly.
and that cuts down on the glare.
Yeah,
Okay, so we got polarization,
right.
we got diffraction, and then there's also dispersion, right?
Ah, dispersion. This is a fun one.
Yeah.
So dispersion is why we see rainbows.
Okay.
It's because different colors of light bend at slightly different angles
Okay.
when they pass through a medium. So like a prism.
Okay.
So that's why white light, which contains all the colors,
Right.
spreads out into that, that rainbow spectrum.
Oh, that's cool. Okay, so we've talked about all these different behaviors of light.
Right.
What are the different types of optics?
So one way to think about different types of optics is by the scale.
Okay.
So like how big are the things that we're looking at?
Right.
So there's something called geometrical optics.
Okay.
And that focuses on how light travels in straight lines and how it interacts with things like lenses and mirrors.
Okay.
So that's like, telescopes, microscopes,
Right.
your eyeglasses.
Right. Okay.
But then we can also look at the wave nature of light. And that's called physical optics.
Physical optics.
And that deals with, things like diffraction, interference, polarization.
Okay.
And that's where things like holograms
Yeah.
and lasers come from.
Okay.
And then, things get really crazy when you get to quantum optics.
Quantum optics.
Which is like the study of light at the atomic level
Right.
and subatomic level.
Right. So this is like a whole nother level.
This is like where we rewrite the rule book.
Right. Yeah.
For how we interact with light. Imagine being able to control light at the level of a single photon.
Yeah.
That's like the kind of precision that could lead to like unbreakable encryption.
Right.
Or, super fast quantum computers.
So quantum optics is kind of like the future of this whole thing.
It's where like the really mind-blowing stuff is happening.
Okay. Okay. And then speaking of like revolutionizing technology, we got to talk about fiber optics.
Right, right.
Like that's changed the world.
It's totally changed how we communicate.
Right.
So fiber optics basically uses these really, really thin strands of glass
Okay.
to transmit light signals
Right.
over really long distances.
Yeah.
And they can do it like super fast,
Right.
super accurately.
And this is like how the internet works.
This is the backbone of the internet.
Okay.
It's
Yeah.
how we can send, information across continents in the
Yeah.
blink of an eye.
Right. Because we got the internet. But
Yeah.
it's not just communication, right?
No, it's not just communication. It's also used in things like medical imaging.
Right.
So like endoscopes
Yeah.
use fiber optics to let doctors see inside the body
Yeah.
without having to do major surgery.
Yeah, that's pretty amazing. Okay, so we've talked about some of the different types of optics. Let's talk about some more of these like real world applications. Like what is optics used for?
Oh, optics is everywhere. You mentioned medicine.
Right.
Endoscopes are a huge one.
Right.
It also, there's optical microscopes
Yeah.
that let us see like the tiniest little details of cells and tissues.
Right.
Laser surgery
Okay.
uses optics to do like really precise, minimally invasive procedures.
So, it's pretty wild to think that something like seemingly simple, like light,
Right.
can have such a big impact on like our health.
Yeah, it's incredible.
Yeah. Okay, what else?
Well, astronomy. Telescopes, right.
Yeah.
They use the principles of optics to let us see deep into space.
Yeah.
We can observe distant galaxies,
Mhm.
try to figure out, like, the mysteries of the universe.
Right. And that's all because of optics.
All thanks to optics.
You can see things that are like billions of light years away.
Yeah.
It's crazy.
Mind-blowing.
Okay. What about just like everyday stuff?
Oh, everyday stuff, too. Cameras,
Yeah.
projectors.
Yeah.
Our smartphones, they all have tiny little cameras
Right.
that use optics.
It's crazy.
Even a simple pair of binoculars
You're right.
uses lenses
Yeah.
to enhance our view of the world.
Yeah. Okay. And then you got like VR headsets and stuff,
VR headsets.
which is like completely changing how we experience
Yeah,
reality.
right. They create these immersive experiences
Yeah.
by manipulating light and basically tricking our brains
Right.
into thinking we're somewhere else.
That's pretty cool.
Yeah.
All right. So I think we've covered a lot of ground here.
Yeah, we have.
We've talked about, what is light?
Right.
How does it behave?
All the crazy things it can do.
Yeah. There's both a particle and a wave.
Yeah, it's wild.
And then, we've talked about like all the ways that it's used in the real world.
Everywhere you look, pretty much.
Yeah, I mean, optics it's a pretty amazing field.
It really is. And the crazy thing is, it's still evolving.
Right.
Like, we're still learning new things about light.
Yeah, I mean, who knows what the future holds?
Exactly. I mean, could light be the key to, like, even faster communication?
Yeah.
More precise medical treatments? Maybe even, like, unlocking the secrets of the human brain?
Okay, so I'm going to be thinking about that tonight.
Me too.
That's pretty mind-blowing. Well, hey, thank you for taking us on this deep dive
Yeah, this was fun.
into the world of optics. Hopefully everybody out there learned a little bit
I hope so.
about this amazing field.
Mm-hmm.
And yeah, we'll see you next time.
See you later.
All right.
Bye.